Alright, in section 3 we're dealing with proportions. So we're talking more about hypothesis testing and proportions. And on some of these are actually giving us the output from calculations, which is important. A survey of 1,646 random selected adults showed that 578 of them have heard of a new electronic reader. So that's kind of where we get a proportion. Let's kind of look at this just to see where they're getting some of their numbers. 578 divided by 1646. So that's that 351154, the sample proportion. The accompanying technology display results from a test have claimed that 37% of adults have heard of the new electronic reader. Again, 35% and 37%, that's not exactly the same, but is it close enough or is it too far away? So that's what we're kind of deciding. Use a normal distribution as an approximate to the binomial distribution, and assume a 0.01 significance level to complete parts A3. So on this one, is it a left-tailed, is it a two-tailed, or right-tailed? Now, since the accompanying technology display results from a test of a claim that 37% of adults have heard of the new electronic reader. If it was more than that, that would be great. If it was less than that, that would kind of be a bummer because they're trying to get their information out. Let's see, use So if I'm looking at this, I'm thinking that I'm trying to show that it's not 37%. Is it lower or is it higher? There's nothing that really says increased or decreased or above or below, so I'm going to go with it's a two-tailed test. Good. Those are tricky sometimes. The test statistic, well, they've given it to us. It's up here. And I'm going to show you how to get this on StatCrunch. Oh, two decimal places. I was like, they gave it to us. How could that be wrong? The p-value they've given to us. Again, so we're just duplicating what they've given us. And the null hypothesis is that it equals 0.37. Since it's a two-tailed test, that means that the alternative hypothesis would be not equal to. And we're comparing our p-value to our alpha. If our p-value is less than our alpha, we would reject the null hypothesis. If it's greater than our alpha, we would fail to reject our null hypothesis. There's a fun little saying, if the p is low, the hoe gotta go. So our p-value is not less than our alpha. Therefore, we would fail to reject the null hypothesis because the p-value is greater than the significance level. So that kind of walks us through our problem. I want to show you, though, where all these numbers come from. So if we're looking at this box in number 2, because this is what we're going to be doing in the rest of this section, is creating this box. So in StatCrunch, I'm going to show you how you get all these numbers, except for critical values. To me, critical values aren't as important, but I'll show you how to get those as well. I believe in looking at p-values to determine information about a hypothesis. So if we go to Stat, and we go to Proportion Stat, and we have one sample, and we have Summary, because we're just given the total numbers. The number of successes is 578. The number of observations is 1646. It's believed that it was 0.37, and our alternative is that it's not 0.37. So that's all we're going to do, and we're going to get all the values that they got. We have the test statistic. We have the p-value. It tells us what our sample proportion is. Again, that's just dividing those two. It doesn't give us our critical values, so let me show you how to get the critical values. since we're dealing with a normal calculator, and it's to the left and to the right, so to the left and to the right, I guess we'll just use a standard. If I want the sum of to the left and to the right to be 0.01, that means that the area would be 0.005 to the left and to the right. So that gives me 0.5%, and over here would give me 0.5%. So this becomes my critical value. Any test statistic past this negative 2.58 or above 2.58 would mean I'm in the rejection region. These shaded regions are rejection regions. I believe this is called the classical approach. Most people today just use the p-value approach. If the p-value is greater than your alpha, you fail to reject. If it's lower than your alpha, you reject. But this is how you find critical values. And let's just verify negative 2.58, right? So that's where we got our critical values at. Let's do one more from this section, since I just kind of walked through how to do a problem where we could see what the numbers were. I believe on number 10, they don't give us the numbers, right? So first we have to identify the null and alternative hypothesis. So we have a big survey. 25.7 reported that bosses screamed at employees. Use a 0.05 significance level, this is our alpha, to test a claim that more than 1/4 of people, so that's 25%, say that bosses scream at employees. How is conclusion affected after learning more than 1/4? Okay, I like seeing those more than words. How is a conclusion affected after learning that the survey is an online survey in which internet users choose whether to respond, identify the null hypothesis, the alternative hypothesis, test ticket, p-value, conclusion? So we have all these things that we're going to identify. Identify the null and alternative. Well, it's believed that it's 25%, right? But how is to test claim that more than 1/4? So the more than is a greater than statement, right? So it's believed that it's 1/4. Our sample gave us something more than, but we're testing the claim that more than 1/4. So here's our alternative hypothesis, more than 1/4. So that means we're one tail and we're a right tail. Now the test statistic, if I go into StatCrunch and I go to my proportion stats, since I'm dealing with proportions, with summary. Now, in this case, I don't know what my number of successes in I do know my number of observations, but I don't know my number of successes. But I could figure that out because I know that I have 25.7% of the 61,648. So roughly we'll go 15,844. And my P was 0.25, and then my alternative was that I was greater than 0.25. So I get my test statistic, I get my P value is really small, and there's that 25.7%. So my test statistic is to 2 decimal places, 4.02. The p-value is really small, so I'm going to go 0.0001 because that's what we have, right? It's actually less than that, but identify the conclusion about the null hypothesis and final conclusion that addresses. Now my p-value is really small, so my alpha is greater than my p-value. If the p is low, the hoe gotta go, so it's lower than my alpha. So I want to reject the null hypothesis. There is sufficient evidence to support the claim that more than 1/4 of people say that bosses scream at employees. If the sample is voluntary responses samples, the conclusion might not be valid. Because again, if it's a survey, the people that are really for something or really against something are the people that respond back. And so it may not be valid.